So this is a short talk on a new package we are developing, not released yet. So to prove that it's still working, I'm running this in a notebook, a live notebook. So hopefully, cross my fingers, and it will work. So this is a package that can be used for time structure modeling in JuMP. So it's a joint work with my colleague Lars Hellemo at SINTEF. So I'll just. So yeah, so we work at SINTEF, a large contract research institute in Norway, and we've been working quite a lot with MIP models, large MIP models in various applications. And for the last few years, we have turned a lot of these models into JuMP, sort of by the promise of sort of this flexibility performance. But for us, one of the key points was the availability to make more modules, because we were tired of these huge monolithic models we were doing in most of like 20,000 lines of code, and it's a hassle to keep up with. So one of the things we were facing then is to try to make smaller packages that supports a specific functionality. And one of the first things we started with was to look into the time modeling, which is quite a simple thing. But it can grow and be more complex as you go on, because a lot of real-world optimization problems involve planning over multiple time periods and also different time scales. Typical examples are long-term investment models, where you combine it, so you have to make strategic decisions based on operational modeling with short time frames, varying time durations. So that's our motivation. And the motivation is here sort of to ease the model development, to enable code reuse, and also to less development time. So what is the basic idea is that for us, a time structure is then an iterable sequence of time periods. Fairly basic. And then you have time profiles that provides values indexed by those time periods. So that's sort of a very simple idea. And we was playing on along and see what that will lead us. So could we make a well-defined API on top of those ideas, and to make sort of a package that lets us make optimization models independent of the time structure that you use? You could be flexible in what kind of time structure you want to use. So basic time structures are like these, fairly simple ones. So you can have uniform time periods of uniform duration. You could specify the durations, so have varying time duration. And you can also do things involving calendar time. So having calendar arithmetic, for instance, could be in some applications. So these are the building stones. And then you can do multiple time scales. So you have two levels. You have these green ones here, which are at a strategic level. And under these, you can have more operational periods, reusing those structures, those basic structures, in a two-level approach. So here you can see that you have 4 strategic levels of a certain duration, and in each strategic level, top level, you use a simple uniform time representation. And then you have the time profiles that provides values for these time periods. So you can have, for instance, fixed profiles that have just a fixed value for all time periods, whatever. And you can have operational profiles that has a value that varies with the time period. And there are even, we have even more complex ones when you go into two-level structures with strategic profiles, and you can also have scenario profiles. I'll show. So I'll just quickly show that we also have more complex time structures that work with the same API. So you can have multiple operational scenarios. Typical in, for instance, solar and wind applications, you do not know what the wind is going to be. So you may have multiple ones with given probabilities. So you're closing in on stochastic programming approaches. And you can also do scenario trees with these sort of combining these basic structures. So here you're combining the operational scenarios with the basic simple times into a more. So you're building upon and always having well-tested underlying structures. So yeah, and then you can be quite flexible. So you could sort of, yeah, see if I can do. So for instance, yeah, increasing the number of scenarios. You can play along. So you can start out with very basic structures, and then you can introduce more complex structures without changing your optimization model to a large extent. So how does this look in JuMP? So there's a basic example. You define your periods on top there. You make some profiles. And then you can index your variables directly on these time structures. And then you can do iterations. So this time period structure is an iterable sequence of time periods. So you get a very natural modeling of things. So it's fairly easy, and then you can start out with very simple time structures, like here, with a simple, like 2 time periods. And then it's easy, sort of, your model, then it's easy in the development. It's easy to debug. You can start out with a fairly simple structure, fixed values for your profiles, and then you can extend things. So it's sort of keeping your model the same, but you can go on to more and more complex time structures. Yeah, and if you want to do a tool level, the previous one was more like a battery model, but on a strategic level, you want to set your capacity at the correct level. I guess it's hard to say, but it's fairly then simple to, you just keep your operational model as it was, and you just introduce a new variable there, capacity, that is indexed by the strategic periods of your time period structure. So it's just a function in the API here. And then you add a constraint that sort of says that the state at each time period is less than or equal to the capacity. And then the other constraints are just the same as you had in your previous example, where you're just looking at the operational side. So yeah, and then you can see, yeah, that you get a more complex model. And you can play, so it's fast here to start out simple, but you could sort of change your time prof structure dynamically and see what happens. So to summarize, I've presented a package for high-level modeling in JuMP to facilitate code reuse. I think sort of there's a benefit of Julia and JuMP to get these more generic packages to simplify the modeling. And I think there's quite a lot of things potential for this kind of more high-level modeling than we're seeing in JuMP to get code reuse among different people. So we're not looking at time structures. We are also working a bit on storages on top of that, for instance, as a more generic concept, and also investment strategies. So the package is not registered yet, but will shortly be available on an open source license, hopefully in August. Holidays in Norway is a serious thing, so July sort of came a bit too quick for me, but yeah. But if you're interested, just come and ask me and I'll show off things more, but it will be available in August, hopefully. So thanks to all other who contributed, and also financial support.